All right. This is the first of 3 videos for today's lesson. First video is going to be going over Unit 7, Day 4 homework, which you should be submitting right now. The next video will go over the Unit 7, Day 7 warm-up, and the video after that will go over the Unit 7, Day 5 notes. Next class is going to be a review day, so I cannot stress the importance of following this agenda pretty strict today. Go through the homework, watch the video key, hopefully that answers some of your questions. After that, go through the warm-up, and then watch the notes before going to the homework. Okay. Question 1. For any rhombus JKLM, decide whether the statement angle L is congruent to angle M is always, sometimes, or never true. I think the only options were sometimes or always. Because it is a rhombus, the one thing that we know about rhombuses, at least the very basic thing that we know, is that all 4 sides are congruent. In a rhombus, the only thing we know about the angles are the same thing that we knew about parallelograms, right? That opposite angles are congruent and that consecutive angles are supplementary, right? Because a rhombus is a parallelogram. It is sometimes true that consecutive angles of a rhombus can be congruent. If this was the case, we would be looking at a square. Remember, a square is just a combination of a rhombus and a rectangle, where all angles are 90 degrees and all sides are the same. A square is just a combination of those two things. The reasoning for this is that some rhombuses are squares. Not all of them, right? Here is a rhombus that is not a square. Here is a rhombus that is a square. For any rhombus JKLM, decide whether the statement JM is congruent to KL. Well, this is pretty easy, right? JKLM, and what do I know about all the sides in a rhombus? Well, they're all going to be congruent, because that's just the definition of a rhombus. That's the one property we have about their sides. Well, are opposite sides going to be congruent? Yes, because by definition, a rhombus is a parallelogram with 4 congruent sides, and a rhombus is a parallelogram. Opposite sides of a parallelogram are congruent. If you only said one of these, right, I would accept either answer. I don't know what Big Ideas will say if you just said this, if it'll say, no, you got it wrong. I'm not sure. But both of these would be correct. Select all that apply. Classify the quadrilateral. Little tough to see in here. I'll kind of draw it out. But we have this 4-sided shape. Just make it look right. There we go. All of these angles are marked the same, so that tells me they're all the same. Well, that means they all have to be 90 since it's a quadrilateral. And I know that all 4 of the sides are the same. That's a square, right? Since all of these have to be 90-degree angles, because 90 plus 90 plus 90 plus 90 is going to get me that 360 that I need. So I can classify this as a square. I have enough information to say that this is definitely a square. Is it a rhombus? Yes. Is it a rectangle? Yes. Is it a parallelogram? Yes. But the most specific name that we can give is a square. Classify the quadrilateral. Okay, I'll just kind of outline it here. We have that shape, that's 90 degrees, that's 90 degrees, and that is congruent to that. Well, the opposite sides look congruent. That tells me I'm looking at a parallelogram. I have that the consecutive angles are supplementary since they're both 90. So that tells me I'm looking at a parallelogram. But what else do I know? Well, I also know that opposite angles are congruent since it's a parallelogram. So those are all going to be 90. I'm dealing with a rectangle. right? That side is congruent to that side. I know that because we're dealing with a parallelogram. That side is congruent to that side. Because we're looking at a parallelogram, right, I know that these are 180 degrees, right? These are supplementary. What do I know about opposite angles? They are congruent, so those both have to be 90. Rectangle. All angles are 90 degrees, opposite sides are congruent. Classify the quadrilateral as specifically as possible. Opposite sides are congruent, or sorry, opposite angles are congruent. Opposite angles are congruent. We also have that consecutive sides are congruent. Well, opposite angles being congruent, right? So 40 and 40, 140 and 140, tell me that this is a parallelogram. Whoops, spelled it wrong. Tells me that we're dealing with a parallelogram. I know I'm dealing with a parallelogram, but what else do I know? Well, in a parallelogram, opposite sides are congruent. So that side has to be congruent to that side. And this side has to be congruent to this side. They all have the same mark. They are all congruent to each other. That's 4 congruent sides, rhombus. That is a tough one because you have to know, okay, opposite sides are congruent, opposite angles are congruent. That's a parallelogram. But what else do I know about parallelograms? Opposite sides are congruent. So all the sides are the same, right? That's a tougher one. Opposite angles are congruent and adjacent sides are congruent. That would just mean that all adjacent sides are congruent. Okay. This one I know we're going to struggle with a little bit. Rhombus DEFG. DEFG, there's my rhombus. What do I know about rhombuses? Well, all 4 sides are the same. That's not going to help me in this problem. I see some diagonals. There are 2 things that I know about the diagonals of a rhombus. Is that the opposite angles are bisected, which means that they are each cut in half, right? So this larger angle G is cut into 2 congruent pieces. Same with here, E, cut into 2 congruent pieces. I also know that the diagonals are perpendicular to each other. So we're going to have a couple 90-degree angles. In a rhombus, right, these properties are going to be different in a rectangle. Might be different in a square. It's not different in a square, but it might be different in a rectangle. We have 2 properties about the diagonals of a rhombus. Their angles are bisected, and the bisectors are perpendicular. Here's kind of the bigger picture. Since this angle is 27, angle 4's got to be 27. Right? I know that those 2 parts are going to be congruent to each other. They both have to be 27. Well, what do they add up to? This entire angle, angle E, is going to be 54 degrees. Well, what's angle G going to be? Also 54 degrees, since opposite angles are congruent. But angle G is also cut into 2 congruent pieces, which each have to be 27 degrees, right? So that's how I get angles 1, 2, and 4. 1, 2, and 4. I also get angle 3. Angle 3 is where my 2 diagonals are intersecting. All of these angles right here are always going to be 90-degree angles in a rhombus. From here, what do I see? Well, you have options. I see a triangle right here, triangle right here, triangle here, or triangle right on the bottom. Technically, yes, you could have a triangle right here, and then you just have to divide that by 2, but let's not deal with that. Let's just look at one of these triangles specifically. 180 minus 27 minus 90 is going to get me x 63. That's how I would get angles 5 and 6. 5 and 6. Right? They would both have to be 63. For any rectangle, WXYZ, decide whether the statement angle W is congruent. Well, this is easy. We don't even really have to draw this out. What do we know about rectangles? All the angles are 90 degrees. So angle W and angle X always have to be congruent. They always have to be because all of these are 90 degrees. Whether they were opposite angles or they were consecutive angles. They all have to be congruent. They all have to be 90. For any rectangle, WX, YZ, determine whether the statement is true. WX is congruent to YZ. WX, YZ. Are opposite sides congruent? Yes. That's not even really a property of rectangles. That's a property of parallelograms. But since a rectangle is also a parallelogram, then that also follows for rectangles. For any rectangle, WX, YZ, decide whether the statement WX is congruent to XY. So now we're looking at a different one. WX and XY. In this picture that I drew, it is clear they are not congruent, right? WX is not congruent to YZ. Maybe this is 3 and that's 10, right? I don't know. But there is a way that I could draw them to be congruent. WX and XY. Maybe that's 4 and that's 4. Well, if I drew it this way, where all angles are 90 degrees and adjacent sides are congruent, well, then that means I'm just looking at a square. Is a square a rectangle? Yes. It is true that some rectangles are squares. Not every rectangle. Here's a rectangle that's not a square, but here's a rectangle that is a square. One of the properties, and I think the only property that we have with rectangles that I can recall, is that our diagonals are congruent. That our diagonals are congruent to each other. Since it's a parallelogram, they are also bisected. But they're congruent to each other. That is always true because we're looking at a rectangle. Trying to see if I can find any other problems that are big that we should go through. Rectangle, what do you know about the diagonals? Diagonals are congruent. WY is congruent to XZ. I just wanted you to find the length of each diagonal, not just X. I know I'm jumping around here. I don't want to spend too much time going over this, because most of these properties are pretty good. If we had any questions about problems 16 through 22, my hope is that the review day is going to help with these. And when I get back on Friday, we might feel a little better on these. Okay? If you have any questions, please let me know. Right? A lot of the struggle that's going to come from this is the fact that we do have a lot of properties, right? I've shown you this tree before. All of these shapes are quadrilaterals, but if it's a parallelogram, then it could be this, then it could be that, then it could be this, then it could be that. Could be a trapezoid, could be a kite, which is actually what we're going to look at today. There are a lot of properties, but if we're pretty strong with the parallelogram ones, then we should be pretty strong with rectangle and rhombus and square, right? We don't have to remember 10 properties for squares. You just have to remember the properties for rectangles and rhombuses. Today, we are going to be introduced to trapezoids, isosceles trapezoids, and kites. We will follow that up in the notes. Please move on to the warm-up.